Think, Learn, Innovate.
Hi everyone. In today's tutorial class, we will solve the differential equation which has a type like this: d square y dx square minus 5 dy dx plus 6y equal to x square e to the power 3x. It has a mixed function of x square as well as an exponential term. So this type of problem usually comes in your makaut first year courses, math, in second semester math courses. So I will do step-by-step solution. Now, if this kind of problem is given to you guys, there will be two types of solution. First, a complementary function solution, and then we have to find out the particular integral solution. Okay. So first of all, I will do the complementary function solution. So to do that, first of all, what I will do here is say, let this equation, this one, I will do the complementary function solution first. Complementary function solution. So in that case, I will rewrite this differential equation in this format: d square y dx square minus 5 dy dx plus 6y equal to 0. Well, now I will take a trial solution and I will say let y equal to e to the power of mx. Then I will do the first derivative of y, dy dx, and what I will get, m e to the power mx. Then I will do second derivative, d square y dx square, and now what I will get, m square e to the power mx. If I do this, I will plug those equation here. So what I get, m square to the power mx minus 5m e to the power mx plus 6 e to the power mx equal to 0. Now I will write down this equation. We got m square minus 5m plus 6, and I got e to the power mx equal to 0. As we know that e to the power mx is not equal to 0, so I will take this equation, m square minus 5m plus 6 equal to 0. Now I can do a middle term break, my square minus 3m minus 2m plus 6 equal to 0. So I get m minus 3 minus 2 m minus 3 equal to 0. So my value is m minus 3, m minus 2 equal to 0. So what are the roots of the equation? Now I will go to the next page and I'll find out the roots of the equation. So what I get here is m is equal to, one value is equal to 2, and m, what I get, the value is 3. So I got the values of m equal to 2 and m equal to 3. And now, as both the values are real and not equal, I can write down the direct solution. The solution becomes complementary function solution, CF. So the complementary function solution y complementary gives me c1 e to the power of 2x plus c2 e to the power of 3x. So that gives me the complementary function solution. Now I will find out the particular integral solution. So to that, I will again write down my differential equation. First, I will write down the differential equation again: dx square minus 5 dy dx plus 6y equal x square e to the power of 3x. Here I will describe I will take let d by dx to be a d operator d. So I will plug here d square minus 5d plus 6y is equal to x square e to the power 3x. So I got this equation. Now I have to find out the complementary function solution. So complementary function, I will say yp is 1 divided by d square minus 5d plus 6x square e to the power 3x. Now note that if there is an exponential term like this, the value e to the power 3x, that value, that 3, I can shift that value here and can bring this exponential term in this position. This is the method by which you can do it. Whenever there is exponential term, please follow this process. Like yp will be like this, e to the power 3x, I will bring that thing before the derivative, the operator d, and I will shift that by d plus 3 square minus 5 d plus 3 plus 6, and I will left with my x square. So after doing this, I will do it here itself, e to the power 3x, and then I will say that d square plus 6d plus 9 minus 5d minus 15 plus 6. So 9 plus 15, so this and this and this will go away, and 65d will be like this. So my yp will become e to the power 3x 1. I am left with d square plus d, and I have x. Now when you got this kind of equation, I will write down the equation again here so that I can write down the step one by one, so that I don't have to go back to the previous page and look back to the solution one each time. When you got this, I will take common here, e to the power 3x, and I will say 1 divided by, I will take d common, and I will say d plus 1, and I will say x squared like this. Well, after doing that, again, step by step, what I will do, I will keep 1 by d down, and this one will be 1 plus d to the power minus 1 dx squared. Now 1 plus d to the minus 1, this value can be expanded in series. And remember one thing, depending upon this x square, you will write down the term here. Remember d, what is my d? D equal to dy dx, okay? So if there is 1d, if I do a derivative, I will get 2x. If d square, I will get only 2. After that, all the values will be 0. So what I will write down here, yp equal to e to the power 3x into 1 by d. Very good. And after that, I will say 1 minus d plus d square plus dot dot dot. And end product is my x square. So if I do that, what I get here is e to the power 3x, where there I had 1 by d, then I got x square minus d, that is my dy dx. If I do derivative of x square, what I get 2x, and if I do double derivative of this one, what I will get 2. Okay, always remember that inverse of derivative is means 1 by d means integration. So what I will do here now, yp equal to e to the power 3x, 1 by d means integration of x square minus 2x plus 2 into dx. Okay, because dy dx here 1 by d means I will do this. So finally what I will get here, e to the power 3x, and I will get here is x square by 2 minus x plus. Okay. So you got yp. So total solution y equal to yp plus yc. And my yc first of all is c1 e to the power 2x plus c2 e to the power 3x. Then I got plus e to the power 3x, and that gives me x square by 2 minus x plus 2. And that's your answer. So whenever, if I go back, whenever you have an equation which given like this, okay, all x square and e to the power 3x, if there is a product of x and 3x, and x square term, x cube or x 4 with an exponential term, always follow this method. So thank you.